Well, good evening, everyone. This week we're in part two of our discussion of a company called Air Street Capital's State of the AI Report for 2024. For those of us that may not have seen the first part, Air Street Capital does this every year, and I believe they've done it since 2017. So they've been tracking AI for a while, and they're a capital company, which of course, I don't know if they actually invest in all companies or if they invest with other people's money or whatever you want, but they are one of those investment type corporations. So they're out there, of course, trying to make money for themselves and money for their clients. As I said, we've done this before, and it's always been a lively discussion. So, and I focus on the discussion part. We definitely want discussion on this. If you see something and you have a comment about it, just stop and let's discuss it. I've gone through their slide deck they've had and added a few more of my own slides and actually edited out a lot of their slides. So we will not go through, we started last week and we got through about into the 50s, but we will not go through the remaining 150 slides tonight, or if we go into a third meeting, during that meeting, I've edited out a number of them. Okay, let me proceed onward. Any questions on that before we do that? Okay, seeing a lot of shaking of the heads, so we're going. So we use the report slides as food for discussion, as I said. We discuss the item, and questions are welcome. Everybody's opinion is just as good as anybody's else. And we're going to skip a lot of slides for brevity, as I said. Okay, not a lot of questions on that, I assume. I'm going to move forward. About the report, this has been produced, like I said, since 2018. I'm sorry, not 2017. And it has these 5 sections on this. We got through the research before, partway through it in the last week. And we're going to go to the industry section. We will not really be covering the politics, but that's kind of interesting. So when we set out the meetup, we set out a link to the original one. And it's also on our YouTube channel, where we have last time's discussion 2 weeks ago. Safety, we're going to do light coverage on it. And then we get to the fun part, which I don't know if we'll get to tonight, but the predictions. Each year they make predictions, and we always like to go through those and say, what did they get right? What did they get wrong? And one of the great things about these guys is they actually check themselves on that. Okay, so that's their cool little starting slide. Oh, any questions on that? No? Okay. These are the two guys, Nate Beniach and Alex Chambers, that put the report together for Air Street Capital. And this is that prediction thing. This is one from 2003. We went through this already, so I won't revisit it if you want to. But you can see they're pretty good about saying, yeah, we got that one, maybe we didn't, or no, we completely screwed up. So we'll get to the one for 2004, though, soon. Maybe, I don't know about this section next week, maybe. Okay, I'm just going to advance. These were the slides from last time. And we will get to one here now when it says we stopped here in session 1. All right, from here we're going to go on. Actually, let me go forward here. Some of the things we talked about, one thing I wanted to bring up, because we'll be talking about again, is how the models are getting smaller, but they're still holding up. If you see this one started with 65K or 64K pixels. This was the real image. And then they tokenized it and reginned it again, and they came out with this image. And then they got theirs down to 32 tokens, and they can still get a pretty reasonable facsimile of that image being generated back. So that's pretty impressive stuff, and we'll see more of this as we go through. Okay. And then there's on-device personalization. They actually have now a few shot adaptation where they're creating a chat model with a persona in 5 examples. So they just give it 5 examples of this persona, and the model can create a chat model that talks that way, maybe with a British accent and a female voice and is smart about mathematics or something like that. So we advanced quite a bit. Okay, but that's where we stopped last week. And this week, yeah, go ahead.
Can you back up to that last slide? It mentioned REFT. I hadn't heard of that before. Does anybody?
Roger, you're breaking up a little bit. I'm sorry.
Oh, okay, sorry. I was just wondering what the REFT is, and if anybody has been exposed to that.
Yeah, okay. That's actually one of my comments. Oh, I should tell you, these yellow highlights, those are mine, and those are the points I'm hitting. And every once in a while, I had to put some extra stuff in, so I put it just in colored text. So if you see that, it's something I put when I was reading this slide. And Roger, I had the exact same question, so that's why I put this in here. So it says, learn a task by task learning by fine-tuning and then applied at the runtime. So I don't know exactly what REFT stands for, but that's in a nutshell what it is. So when they're talking about this 5-shot thing to give it a persona, that's the technology they're using. And they kind of show it here. If you can read in the lower right in figure 2 there, we have an intervention function that is applied to a hidden representation in some sort of layer. And then, oops, you probably can't see it because I got this thing in the way. And then there's a low rank adoption of that. That's what the low REFT is. And as you know, with the low rank adoption, we can run it down on a smaller model, a smaller platform and things like that. Does that answer your question? I'm sorry.
Yeah, that's cool. Thank you. This might be a good topic for one of our meetups.
Yeah, well, you know, every time I go through this, I have that exact same thing on about every third slide. We should talk about that at the meetup. So, you know, if anybody has any questions about these, feel free to stop. Ted, go ahead.
So Roger, I just took a quick peek and kind of confirmed this figure 2 that they're showing here. So in LLM research, there's this idea of steering where on the residual stream for the activations, you can just add a vector and you can push it in a direction. Yeah. And so the trick here is they have to learn what that direction is. And that's the part that I haven't, I'd have to read the paper. But in terms of what they're doing, they're basically just learning a direction and they're just summing those values onto, seems like summing it onto the residual stream.
So is the steering is that injected at kind of the input side of the model, or is it injected multiple layers?
I think it's usually injected partway up through the layers. So like in the Anthropic work where they're doing the superposition and saying, hey, we found like, I don't remember the number was hundreds of thousands, millions of directions associated with things. And they say, this is the direction associated with the Golden Gate Bridge. Basically what you do is, you know, you go say halfway through the layers and they just say, this is direction. They just add that vector to the residual stream and you can add it like a little bit, or you can multiply by 100 and add it. And they showed that you can sort of, this was not meant to be like a usable technique, just meant to show that like this direction vector really works. So if you crank it up enough with some trial and error, you can ask it any question like, how do you, you know, how do you change the oil in your car? And somehow it'll like fit the Golden Gate Bridge into the sentence that's like otherwise answering how you change the oil on your car, you know? So they showed that like with a bunch of random sentences, it'll just sneak it in there because you steered it.
Okay, so different than LoRa, which is what it's kind of modifies the feed forward network. This is just a static bias that's injected into the residual stream, huh?
Right, and then it looks like they then did a decomposition so that the storage requirement for that direction is smaller.
Cool, thank you.
Okay. The important point to me, because I'm, you know, a small device guy, was this last part after the comma. It could be used for real-time personalization on devices with sufficient computing power. And I'm wondering, I did a talk, if you remember, a few months ago on, Apple's version of AI, and now that that's shipping now in their new phones and devices and things like that, I'm wondering if maybe they're looking at adding some of this into those level of devices for personalization, because you're a student, so you're more interested in student sort of things or student appropriate responses versus somebody who's I don't know, a retired teacher or something like that. So just trying to see what they're going with that. It is an interesting thought, though, to have this like adaption to give it a different persona and just a few examples. So you can take your big model, adapt it for some other thing, and still hit a small storage footprint. So that means personal device. Anyway. Okay. And so that's where we stopped last time. I skipped a bunch of slides, but so going on, there were some slides ahead on multimedia. And the big thing is that we're getting now to the point where there are VLMs, vision language models, are getting to the point where they're quite good. If you look here in the lower left, you can see this is 2018, and it said this picture of the baby with the toothbrush is a young boy holding a baseball bat. We weren't too good that good in deciphering what was in the image in 2018. Or a cat sitting on a couch with a remote control. Pretty sure, maybe that's kind of a cat. Looks more like a ferret to me, but okay. But now in 2024, you can say they fed this diagram to it, and the output text you can read over here on the right side. This is them showing a performance test for maximum latency and 1,000 documents using somewhere, it must say it's single thread. Oh, it says single threaded here, blah, blah, blah. And then it tells you what's on the X plot. It tells you what the blue lines mean, yellow lines mean, things like this. I really wish I would have had this when I was in college, and you get that diagram and you go, that your professor put up there and you go, what was all this about? It sort of made sense in lecture, but now I don't remember anything about it. And I would have loved to have had something like this. So, they are getting much better at the vision language models are getting much more powerful in recognizing what they see. So I thought that was pretty neat. Okay. And everything you're seeing highlighted are things I highlighted, so I don't know if these are appropriate or not, but it's what I thought was cool. So this is text to image. Stability AI has continued to search for refinements and increasing quality, blah, blah, blah. So their speed up in image generation has reduced the sampling size just dramatically. You remember, wasn't it just a few years ago we were talking about, oh, we don't have the data and we can't to do these, because we don't have the data set. Well, now these guys are working with, not hundreds of images to train these diffusion models, but like 4 or 5 and things like that. That is a huge, huge step forward in terms of being able to train these diffusion models and things like that. For those that don't know, diffusion models are the ones that let us take like one of these, if you look over here on the right, we take one of these images and then put noise in it and then train it to recreate this type of image, training a discriminator. So that when we get something else that's similar to that, we can then train it to generate an image and also work with things you want. So apparently somebody said, we want clouds and things like that in our image and what have you not. So the models are getting much, much better on doing this. Questions? Okay.
Sorry, I was a little slow. Just a quick comment.
Oh, play back up.
We talk about the what we're really trying to do is invert an arbitrary function that maps between, let's say, I know this is just like full random text, but let's even just do simpler, just like ImageNet between like pictures and ImageNet classes, right? And for a long time, we've said, this is a 40-dimensional problem, and you can't invert that function. But basically, these guys are doing pretty reasonable approximations of the inverse in 4 steps. I think that's just nuts.
Yeah. Yeah. By inverse, you mean from essentially going from noise to your desired target, if you will, or yeah.
So what I'm saying is we can build classifiers easily that tell dogs from cats. But if you ask someone to invert that function and to go from dog to all the pictures of dogs, just
I see
can't
what you're saying. Yeah.
It's such a high dimensional thing and whatever. And
Yeah.
essentially, this is like 4 or 5 steps, and you can, do that pretty well. That's kind of insane if you think about the math.
Yeah. Yeah.
But Dave was asking a question there. So my take on this, because we covered this.
Hey, Roger. So, just FYI, I had posted that to you directly. Maybe you want to read the question as well. I can post it on the full channel.
Oh, I didn't notice this. Okay, direct. Okay.
I post it also. Yeah. Thanks.
The question was just looking at this versus consistency model. I guess the way I interpret it is that it's easier for us to learn kind of the gradient of that loss function from the data. And then this process is using the distillation to go back and figure out what is the transfer function, basically. What's the inverse function that you're talking about going from latent space to image? And so that's what they're talking about here. And the 1 to 4 is the number of steps. So you can get, if you go straight back, you can't necessarily go from latent all the way to image, but you can take, 4 steps getting there. That's the way I understand this to work.
I think you're right. It's a speed up. I think that they're pushing in this slide. Is we used to take us hundreds of steps to do that, and now we're down to 4 because our algorithms and things like that are that much better. Dave, do you have anything to add to that?
No, not right now.
Okay.
Just wanted to maybe, add that consistency models, which are, I think, a part of Stable Diffusion 3.5, which is from Stability AI. And they do claim generating an image every 0.01 second or even faster than that. And if I I don't know the cluster size. I mean, it's dependent on many factors, but nonetheless, or the GPU, or the model size, and the inferencing farm size and all. But nonetheless, if I'm not mistaken, they do use consistency model. Their code is open source, so we should, or maybe, as part of this group, we should look at it at some point in time. If I'm not mistaken, this paper, the one that we have on the bottom right, I thought it was from NVIDIA, but this slide seems to be talking about Stability AI.
Yeah, well, it may be that NVIDIA has something they're showing as a demo type thing or what have you not, and maybe they're showing stability, or maybe they've come up with something that's more specific to their hardware platform.
Yeah, and consistency model was more of learning the paths that you can take from your noisy images to the actual image in 1 step, or 1 to 4, 2 or 4 steps, just the same way. The approach was slightly different, where they were learning the function instead of learning from the score function, if you may, learning the inverse function from noise to the image. Versus this one is a slightly different approach than consistency model.
Okay. All right, I'm going to move to the next slide. And they're also doing it here with video and things like that. You can see now they're trying to create high-res video sets quickly. So these are just random frames in these samples that you can see, but they are getting pretty darn good at this. I like this one personally, the exploding cheese house, but that's just me. But they're calling it stable video diffusion. So it is a diffusion at not just a single image frame, but at videos where you're maintaining consistently across frames and things like that. So that's a pretty big accomplishment, in my humble opinion here. They kind of go through their things here: 3-stage approach, image pre-training on a large text-to-image data set, video pre-training on a large curated low-res data set, and fine-tuning a smaller high-res data set. So they're upscaling then. Yeah, and they fine-tuned on a third object set to predict 3D orbits because, if you're wanting to do a pan and zoom of a video and things like that, they can actually support that sort of thing. So that's pretty impressive. Okay. All right. But these small labs are also having to compete with the big boys. Your OpenAI has something called Sora that does that, and then Google has their VO, which combines text and image, things like that. And I think this video, let's just play this. It's really quite impressive here. So that's generated. So that's some pretty impressive stuff that they're doing. So these are all, pure generated high resolution video. And I'd kind of be hard pressed, I think, to tell some of these from real life, somebody went out with a camera type thing. But obviously you couldn't go, that's not real life. But anyway, I won't bore us. There's 10 minutes of this, but I just thought we'd take a look at these just to see what they got. Questions? Thoughts? I guess we shouldn't try to get into the filmmaking business unless we're going to use AI or something like that. Okay.
Just wanted to add that this space of video generation is, definitely the next frontier, if you may. And this, I don't, I was looking at something else to get you a link, essentially. So there's this model called Mochi One. So this is not yet end of 2023. Of course, this report has come out before the end of it, but third week of October, a model called Mochi One came out, and it was at the top of the leadership, and it is open source for video generation. Of course, I don't know if the model is open source or everything is open source. So, open source definition is changing quite a bit as we go along. But in this current age, anyhow. I posted the link to that video leadership arena, and Mochi One apparently hit waves.
Yeah. I don't know when they locked this thing down. I mean, they shipped this list out in like at least 8 weeks ago now, or 6 weeks ago, or something like that. So, it's way out of date, right? Because of the rapid progress, like you were mentioning, Dave. So.
Yeah, the last line which talks about Gen 3 Alpha from Runway, apparently that is number 3 in that leadership board.
Oh my gosh. Yeah, well, watch this space and don't blink, right? Or something like that, if you're watching that space. Okay, I'm going to move on to the sacred sign. And Meta goes even further, us. And of course, Meta has their things here. Let's see, and they're doing it with a relatively small, models, 30 billion and 13 billion audio, doing 16-second videos at 16 frame per second, or 45-second audio clips respectively. So that's pretty impressive. And here's some of their output, just so we see. Anyway, I think it's pretty impressive. I guess I wouldn't want to be working the special effects in Hollywood, or unless, I'd be spending my time, I guess, getting pretty good at these tools, because you got to figure that those will be, really pushed out and be game changing to what we see in movies and things like that in the next not too distant future. Okay. Comments from anybody on that?
Sorry, I just had a interesting thought that this might bring up. So I'm sure a lot of people know, for example, that like a lot of mainstream and media news is dying, or when you walk around kind of town or whatever, you see a lot of like flashy advertisements and stuff like that. And so that actually leads to kind of an overstimulation, or kind of a back of that kind of like cheesiness, like this isn't the real thing that I want. So that's what led to a lot of like longer form kind of discussion about real stuff. I'm curious if you guys more or less think this is going to happen, where we're like, most people are already tired of commercials. I can see someone using this to bang out 30-second, 45-second commercials like crazy. So they start like craving longer documentaries and stuff like that done by real people, almost like the news effect. Like it's too easy. There's too much of it. It's overstimulating.
That's an interesting question, because, people do crave, when it's so easy to generate, people do crave well-written content and things like that. They always have. I mean, I know a number of my friends that, just love having a physical book, just to read, to hold, to have the printed word in front of them, and to then absorb it at their pace, rather than this thing shotgunned out the screen or through your headphones or whatever, just shotgun into your head. You can just go back and, incorporate it into your day and things like that. That'll be interesting, what people end up doing with that.
Yeah, a flip side may be that this type of technology allows you to have kind of targeted videos or advertising or whatever that really does pique your specific interest.
Yeah, that is like an advertising person's dream, right? That they can, get you to buy XYZ because they know you have these 50 characteristics and I can hit 35 of them or something like that, whatever.
That's right. Somehow we in the sales of detergent, we were able to bring in the cat and the horse and the unicorn that you like.
Yeah. And, serve it up. And then, to companies like YouTube, like showing this video, they gather enough information about us, unfortunately, that they can probably sell that to an advertiser, so that the commercials we're served up are very customized, because the cost to generate is low, right? So, and, I imagine a company like, Meta or somebody like that would love to be in the driver's seat for that, so that they can sell to advertisers that, that service that they have. It's a brave new world, and maybe AI won't kill us, but it may oversaturate us and things like that. And to Brian's point, maybe it'll be kind of, just be something we just sort of block out maybe over time and things like that. You know. Interesting. We're in a strange, very rapidly changing world. Okay. Oh, wrong thing. No. Okay. So I broke up, they had this big long section and I sort of broke it up into subsections here. So if you see one of these slides, this is me where I kind of said, oh, we're going to talk about science and AI. So the big thing, of course, that we all know about is, we saw that, AI researchers are getting the Nobel Prize. And that's pretty impressive. We get the Nobel Prize in Physics from John Hopfield and Jeff Hinton. And it says here for fundamental discoveries in machine learning, artificial networks. Yeah, so the basics and things like that. But in an applied space, we see over here in the chemistry that we have protein structures and things like this. My eldest daughter happens to have a PhD in molecular biology and works in this space. And she says, yeah, what they did will fundamentally change the approach of how drugs are manufactured, how we come up with, try out new drugs and things like that, and we'll be able to produce more drugs and therapies and things like that in a much, much faster pace and be able to address a lot more diseases. So good and bad, I guess, with every tool always has a good and bad. But it's amazing that in just a few years that AI has become, brought out and machine learning to the broader world and broader community. Okay. And speaking of which, we have talked in this meetup, I know about AlphaFold and AlphaFold 1 and 2. And AlphaFold 2 went up to proteins and their interactions. But now AlphaFold 3 has gone into much larger biological molecules. Blah, blah, blah. And you can, I don't know a lot of this. You're talking to the wrong Karada. You need to talk to my daughter about a lot of these. And she would be able to give us a long dissertation on this. But essentially what they're doing is they're able to find sequences and have templates and do genetic searches and then input it to an embedder that then generates these diffusion model to generate these structures. So you say kind of what you're looking for, what genetics and things like that, and it creates a diffusion model that can generate molecules that match kind of what you're looking for. So if you're a biochemist in the area of, let's say, mental health or something like that, it can help generate the drugs that are potential drugs or drug molecules that you might want to build into a product. And when I worked for Novartis, we did this in the lab, and this was multiple millions and millions and millions of dollars. Literally, drugs, when they're produced, a lot of drugs are produced, and there's like this big funnel, and you have a lot of them falling by the wayside, and only a very few of them get to from into a stage 1 trial, then to a stage 2, and so on. And then you have to get beyond that to even get to market. So up until then, you've essentially been just spending millions and millions and millions of dollars, and you might get to a certain phase and realize this just isn't going to work. And if these guys can cut that down and so that you get to a more promising molecule in silicon, then that would bring a lot more molecules to the drug market or treatment market, if you will. So hopefully we'll end up with better help for that. And I did highlight this one bullet point noticeably. No open source has made available yet. I don't think it's ever going to happen. Be open source or maybe a stripped down version. If anybody else has heard anything, let me know. But I think that becomes very, very corporate, like the corporate jewels, if you will, on building some of these things. So we'll see. Okay. And yeah, they're getting out of, they're trying to build more things like that. And The interesting thing I saw was that Baidu was one of the first. I hadn't heard of them in this space, playing in this space for a long time, or ever, I should say. And it's interesting that they're in that space. So I imagine they're looking at just doing commercial drug discovery for the companies in Asia and throughout the world. I imagine they'll sell a package or something like that. And this other company, Chai One, is being backed by OpenAI. So now OpenAI is backing their own companies and doing molecular prediction, which is the tough problem, because you want to predict the molecule that'll work and it will have these properties, but you also want to make sure it's stable and doesn't, like, as soon as you take the pill, it doesn't just fall apart in your digestive tract. Or if you infuse it in a patient, it doesn't have, horrendous side effects, things like that. Let's see. Will Alpha DeepMind fully release AF3 sooner if they begin to fear alternative models coming to the community? Good question. It is a race. It's $1 billion race, so everybody wants to play. Ted, you had something? Comment?
I mean, kind of a random comment, but the diffusion models were sort of first inspired by Brownian motion. And I think it's kind of funny that AlphaFold 3, like when they're doing prediction of a small molecule, then it's basically they start out with, the chemical formula, so you know how many atoms you have. And literally they migrate around until they align into a 3D structure, right? And so it really is like if you took them and you took away all the bonds and you just had Brownian motion and they all floated, and then you just tried to reverse that process. So it's actually,
you think it's purely random that they do that, or?
But I mean, like
they have rules, right?
When I think of adding Gaussian noise to an image, I don't I know the mathematical connection to Brownian motion, but I don't think of it as Brownian motion. But in this case, I think it literally is. They say if it's DNA, then you have your whatever, your four, I forget what they're called.
AGT, whatever, the amino acids, right? Yeah.
You're doing whatever, but yeah, the base pairs, whatever, right? Base pair, yeah. So in this case, the base pairs or the individual atoms, they just start out like, let's say, flat on a piece of paper, and then they move around in 3D until you have your final structure.
Yeah, and it has to, in the folding, if I remember right, doesn't the folding have to be done? I'm trying to remember. There's not rules, but there's it only works if the folding is done in a certain way or things like that too.
Yeah, because proteins are actually, the shape of the protein dictates the function. So how it's folded and how it's shaped is very important.
Right.
Because if it's folded, it can actually become a prion, which causes other proteins to misfold. That caused mad cow disease back in the England 1800s.
That's a bad thing. Brian, that's definitely bad. Yeah, so thanks for bringing that up, Brian. That points that they can do in silicon some of this testing and probably knock out some candidates versus, when I was in the drug business, and I'm sure if I asked my daughter, they're still doing some of it. A lot of times they push things through internal trials and things like that, and it just dead end. And so this can kill, the dead ends early on and things like that in the computer, probably in hours versus 4, 5, 6 weeks in the wet lab, or whatever it takes to do that at a much lower cost. And, the way it works in drug discovery is the more times you're at bat, the more times you're going to get on base, just like anything else, I guess. So that if you can cut that time frame down, you can cut the budget down, you can get more, times attempts and things like that. And hopefully it'll come out with some, novel things that will solve a lot of things.
Hey, Ted, shout out. That's a very cool insight between the similarity between protein diffusion versus diffusion models, or Brownian motion versus diffusion models.
Yeah, I would agree. All right, let's move on here. Yeah. If you go to the thing I highlighted there, so the whole protein design field is kind of this, the filtering, as I say, is more important than the generative modeling because it's the ability to kill. You generate a ton of candidates and you kill the vast majority of them. So if you can kill faster, you can bring product to market faster. That's just how that works. And you can spend less money because, you know, you're paying PhD scientists. And if you get to the point where you get to like, you know, lab tests, you know, in biologics, like a mice or something like that, you're just, the money is just going up exponentially and things like that. The time is going up exponentially, the number of people involved. So if you can kill things and just realize, oh, cut that branch and just move on, you're really, really better off from a business standpoint and from a scientific standpoint. Because I've seen, you know, scientists that were just like at their wits' end because they went down this path and it turned into a blind alley. So it is difficult business to be in. Okay. So yeah, experimental biology. But I thought this was interesting. A secretive protein design team at DeepMind came out of stealth mode. So that's, I guess, not surprising, but I didn't realize they were operating in stealth mode already. So, yeah. Okay.
I think they have a company called Isomorphic Labs or something. Is that the one?
Do they?
Yeah.
I don't know. Is that what it is?
Yeah.
And they announced it. They were running dark for a while, I guess.
I think earlier this year or maybe they were all there all along, like one of those moonshot projects or companies. And now it's in limelight.
Oh, okay. Okay. Well, yeah, you got to, you know, justify all this expenditure somehow to your shareholders. And, you know, so you have to, that management's probably playing a little bit of a game by doing that, just dropping pieces, you know, enough to kind of quiet the noise on the burn. Okay. Okay. This is kind of cool stuff, I thought, from my perspective. So if you're familiar with functional MRIs, so you essentially attach to watch, or, you know, you watch a person's brain and things like that and try to figure out what segments are lighting up and things like that. I think, oh, they have a picture here. So they have recordings of it here, and then they're figuring out what parts of your brain are firing up and things like that. And being able to map that and create a visualization here. They're showing this latent space where they have an attention visualization. So when you do this, what lights up in your brain, what regions are, and then we'll see in a little bit when they do drugs and things like that, which ones attack and things like attach themselves to structures within those. Yeah, so they're talking about it doing things, being able to use this modeling to fine-tune particular chemical variables, blah, 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 age, and anxiety disorder scores, which I thought was bizarre. They can actually make a drug or treatment that is based on your level of anxiety. That's pretty first level type stuff. So that's interesting to me. Okay. Okay. So we're out of the human stuff and going on to kind of atmospheric stuff. The biggest thing, if you've ever studied any sort of atmospheric science is like an NP complete program, you know, just computationally really super hard. So the forecastings and predictions that you get now, I'm trying to remember how they're done, but it's sort of like this, we can't figure it all out because we can't figure out all the interactions. So we're going to segment the areas and just calculate them for this little area and then kind of put them together and see how they all line up. It would seem a little not like a complete thing. but they're talking about being able to do this in a much more complete way for both forecasting just regular weather, and then they mention here global air pollutions and high resolution. This is the big thing: high resolution, medium term weather patterns. High resolution being, we get the temperatures and it's going to rain for Ted in downtown San Diego, but not up at his house because he's 20 miles away, right? Something like that. And the medium term means going out beyond a week. So they'll be able to do that out maybe like 3 weeks. So when you're planning a party or something like that, that, it's not going to rain on that Saturday or whatever. Or if you're going skiing, that it's not going to be a whiteout, so you shouldn't go skiing that week or something like that. Atmospheric dynamics I've heard it described, I don't believe this is correct, but as an NP complete or NP incomplete, I guess, problem, that it's just really, really a tough model to crack. I don't work in that space, so I don't know a lot about it, but I've always heard it described that way. Anybody else know anything about weather prediction? I think they build it into little boxes and just predict boxes or something like that.
So a couple of things that I don't know if they have more slides on that, but Google which is DeepMind, and some models from Caltech, which were based off the original work of the neural operators, which are essentially along the lines of solving at the very bottom layer, if you may, the PDEs, because many of these atmospheric dynamics is tons and tons of PDEs, partial differential equations that need to be solved, and the path is essentially a functional that needs to be identified. So the neural operators help identify that functional for solving the optimal solution, if you may, or taking you towards that, and be able to work at any granularity of data, whether it is at the regional level or the global level, and the granularity means like how much condensed data you have. But going back to the concept, so what used to take supercomputers to forecast, many of these are now being forecast with some 3-year-old GPU-based system, single GPU-based system. So this is truly amazing. Of course, there's always more work and there's always more things that need to be integrated. But you may have seen some of the posts, at least in my feed, coming up from all these models producers, that how they forecast this hurricane path versus the actuals from the Meteorology Center of Europe. And there are two big ones, one in Europe and one in US, NOAA or whatever it's called in Europe. And they compared theirs, and they were actually they were better in some cases than those. But long story short, in my opinion, and that's my personal opinion, of course, I think this is another field where it is ripe for some kind of really high award, if you may. I mean, it has already proven itself to some extent. People are using it. There was this model called Nowcast or something like that from Google, which could do a regional forecast in the next 1.5 hours. So it will be accurate for the next 1.5 hours. So you are in, let's say, town of Pleasanton, and you want to know whether it's going to rain in the next 1.5 hours.
Oh, I see.
Yeah. Exactly whether it will or not. So there is good progress that has happened, and good enough to draw some real good high-level accolades, if you may.
Okay. Yeah, and I was just looking at this last bit here, which says, I guess these newer models are dramatically faster, right? And that's kind of what your point was. Yeah. That's the big thing. I mean, it only took us a week to get a forecast of what it was going to be last Tuesday. But we started on Monday. Ted?
Yeah, so the thing that I wanted to add that I think is a good lesson from Aurora is when I talk to people about about transformers and deep learning, essentially what I say is if you can figure out how to tokenize the data, then as long as you have enough training data, a transformer is likely going to beat any other model that already exists. So if you want to do something with audio, you have to figure out how do I take, the whatever volume levels and tokenize that. If I have an image, do you do 16 by 16 patches? Blah blah blah. For all these different things, how do you tokenize that data? And so that's the approach that the Aurora team took. Is they said, "Wow, we have this cool data from the National Weather Service that goes all the way back to 1879, but it only has these 5 variables. We have this other cool data that's like satellite, blah, 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 and it's got all this great stuff, but we only have 3 years of that. And then the European agency has this, and they do altitude at 12 steps. And then here, NOAA has this thing, and they do altitude at much, much finer resolution. And so it has 120 steps. So there's all this data, but it's all different. And so you have nulls for some of these features, and you have whatever, whatever, whatever. So what they did was they built a universal encoder. You can give it any data you want,
that's what
any
this
granularity
thing
you
is
want.
here. Okay.
And it'll take all the nulls and deal with all that. And it has to find sort of a universal tokenization, even though the inputs from the different data sets have different fields and different granularities for time and different granularities for altitude. And some of them are, 2 square kilometers, and some of them are 6, all that stuff. So that to me is the real achievement that they did, is they came up with a universal encoder. Once they did that, they now had a lot more data because they could use data from anywhere, everywhere,
Gotcha.
And then the latter part is pretty vanilla, right? You put in some historical weather data and you predict the next time step. We all know how to do that, but it's prepping all of that data and then getting that universal encoder to work. So I think that reinforces this paradigm that started with probably the real big one was VIT, Vision Transformer, right? Like if you can tokenize it, it'll work.
Yeah. Cool. Brian, did you have your hand up?
Yeah. So Ted, you actually kind of started a little bit of the train of thought I'm going with. So keep in mind, my background is in statistics. So from my understanding, the problem with weather is that it's so kind of varied in terms of what's actually being measured and how it's being measured. Because if you go back far enough on the data points, we were in an ice age. So my biggest question here, would this thing be able to tune itself to understand that you have to almost section it by there's a reason why we section things by periods, and it doesn't understand that there might be an overall cycle going on, but you're dealing with a new period of time to actually sort of accurately forecast.
That is an interesting question.
Yeah, I don't know tons and tons of details, but my understanding is that if you don't have a direct input that says, for example, the levels of CO2, right, then you can't make predictions for 2 different time periods where the levels of CO2 are totally different. So my guess is that, yes, you either have to input enough things so that you don't have to retrain it on the period. You just have to tell it what the parameters are. Otherwise, yeah, you're going to run into a problem because.
Well, to kind of give you an example, so I don't know if you know this, I think it was Genghis Khan, when he was around, he actually took the carbon footprint off Earth about 10%. So could the machine, if I'm not saying that's going to happen again, God hopes not, but could the machine understand, therefore the parameter has been blown, so therefore we need to treat this as an isolated incident or a whole new thing entirely?
So the intent, I don't really love the term foundation model, but it seems like we're stuck with it. So their intent was to build a foundation model. So that means that it's generalized, pre-trained. And so their answer to you would be, no, you don't need a new model. That's why we pre-train this. You just need to give it the right inputs. So if you tell it that the oxygen level is this, the nitrogen level is this, the whatever smog pollutant level is that, blah, 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 I'm going to very accurately predict, the next few time steps, whatever hours, days of whatever it is you're interested in.
Interesting. All right, let's move along just a little bit if we could. This one talks about, is this the fMRI? Yeah. This is the fMRI, and now they're even going further with the fMRI, where they're trying to use these images to they train the model. They train the model and took a look at that. And in the next subject, well, you can see the subjects here kind of in this region. I'm pointing at my screen with my finger, and I'm not surprised you guys can't see it. So they wired up some grad students or something like this, or maybe undergraduates, or something like that, and then had them watch a number of these subjects and things like that, and to figure out to do a map essentially of what got activated in different parts of their brains when different subjects were presented. And also, they then said, oh, okay, you were watching this video here. Let's reconstruct that from what the signal that you had in your brain, so we know that you're watching that. So that's kind of weird. But the next slide we'll get to is kind of more important, I think, with respect to it. Let's see, looked at 100 rich stimuli. Yeah. And so they could figure out which regions of the brain were active. I'm sorry, this is my comment on the fMRI thing here. And they were doing. Let's go to the next one. So this is more important, in my humble opinion. So they did something similar then with speech recordings and things like that. And they helped somebody, they were able to tell when a patient with severe motor speech damage was trying to say something, or what they were looking at, what they were thinking about at that moment. And then they predicted the most accurate phoneme, the parts of a word and things like that. So they could essentially, by that person looking at something, generate what they were thinking about to give them back their voice. So that's pretty cool stuff. I mean, that's freeing, that this individual has been, forced into, I don't know if you've seen current systems for this, but it's like, you got like alphabet or something like that, and they're trying to spell letters. It's just really old school and things like that. And now they're saying they can decode speech from brain recordings with implanted to enable communications for patients with impaired speech. So that, if they can come up with that, that would take people that, have these various debilitating diseases, which we're seeing more and more of. I know 2 or 3 people in my local community here that have problems now as they've aged into completing thoughts, generating certain words and things like that, and are really turning into homebound because they can't, communicate with the average community. And this maybe would get somebody like that out there, But that's pretty impressive, I think. So you can see they're doing a lot of words. It's not just 50 or 60, but they're doing a lot of words as they add them on, and they're in not too many hours of training. So that is very useful technology. Probably not a real moneymaker, but a really useful, use of our technology.
If I can throw on another comment,
Ahead,
I've said that the best use cases for LLMs are the ones that are inexpensive to verify, right? So if you have an LLM write an essay and you didn't actually read the book that you're supposed to for that class, you don't know if the LLM did it right or not, right?
Right.
But if you ask the LLM, oh God, what was the movie I'm thinking of, whether the actor does this and that happens and that happens, that happens, and it says, oh, are you thinking about the movie, whatever, Apocalypse? Then you're like, oh, yeah, yeah. You can confirm if it's right really, really quickly. So for this one, it would suck if the speech generation wasn't really, really super accurate, but these people still have hearing. So as soon as it says the wrong thing, they can just say, no, I meant to say blah, 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 and correct it. So I think that you can actually tolerate, because what you were saying is right. Like if you have to pick out with your eyes one letter or one syllable at a time, it's super slow. And so if
Right.
this thing can do a natural rate of speech, even if it gets some of the words wrong, you're just like, well, no, I didn't mean wrong. I meant incorrect. And then voila.
Yeah. Yeah. And the thing that's, the thing, if you notice here, they have these confirmation buttons they're working on, 100% correct, mostly correct, or incorrect. It's because, maybe a synonym, maybe not the right, correct version of the synonym, maybe it's like, 60, 70% synonym versus, 100% correct or something like that. And I think that's a pretty smart way to do it. And note they also have an eye tracker so they can tell, which word essentially the person's looking at.
Yeah.
Is this such a, good news and congratulations. So they're tracking where that individual's eye are and they have these various recorder head stages and things like that I assume are picking up some of that motion and things like that. So
yeah, that's for training. But I'm saying once you're just out in the world and talking to other people,
yeah,
you'd want the model to be 99% accurate. But even if it's not, it just means that you have to back up and repeat yourself a few times, which
right.
is still way better than what you were talking about, like picking out one letter or syllable at a time with your eyes.
Yeah. And if you look here, it says the cortical activity was decoded small care 99.6% accuracy being attempted in sequence of phonemes combined into words using an RNN. And then they're moving it to a much larger vocabulary, not just 50 words, but to, thousands of words. So this could give this individual the ability to interact with the vast majority of people, if you think about it. So that's a real good use of our technology. And I guess this is at UC Davis, they're working on it. Okay, let's see. AGI, the golden thing, right? It's just around the corner. We know it's going to happen next year. Or next year it'll happen the year after that, if not, right? I see a lot of shaking of heads here because I think, this has been, been out there for a long time. Let's see here. Francois Chalet, who is in France, as you could have guessed by that name, and created Keras. Are you guys familiar with Keras, the framework that Google has? So I don't know if he's still with Google, but he's probably at that level at Google where you just kind of work on whatever the hell you want. You get to, I forget the term, like a managing engineer or something like that. And they don't bother you, ask you to do anything. You just sort of do stuff. And, every once in a while you produce something great that, helps the company a lot. But anyway, Francois is doing this. He created it. I thought this was something interesting benchmark back in 2019, measured model ability to generalize on task that are easy for humans and hard for AI. And so I think the question was, here he gets to it. He's skeptical of LLM's ability to generalize to a new problem outside of their training data. And he's created a prize that'll hopefully push people in the direction to lead more human-like intelligence. So essentially, how we can sort of make that jump from, we're talking about this subject and an association, I guess. This is like something else, so I know sort of how that works. So this must work sort of like that. And then I put these other 5 things together and boom. Okay, now I think I have an understanding in general of how that works. And I think that's what he's looking for. So far, their highest score is like 46, which is, he was shooting for 85. So we still have a ways to go. And I don't know this Minds AI team. They're using LLMs to expand, but it's an interesting thing. And over here in the examples, you can see essentially what you're trying. This is just showing, you have this sort of thing, and you should be able to infer where the missing piece is missing type thing. At least that's what I as if somebody else knows what that picture is better, let me know. But this is, yeah, as they say, a new challenge aims to refocus the industry on a path to AGI. Whether we get there? I don't know. Anybody know what Zapper is? I didn't know what that company is either. No. Okay.
Zapier is, if this, then that kind of thing, kind of connecting the dots. That's what it used to be. I don't know if this Zapier is different.
Okay. Okay. All right. Well, it sort of fits, where they're doing the price sort of thing, right?
Yeah. IFTTT. I don't know if you have heard the term.
Yeah. Okay. Cool. But they are offering $1 million. So, all right, let's all get working on this here. We'll win our $1 million. Okay. Let's see what's happening in large language models. Researchers are exploring methods to generate stronger internal reasoning process, variously targeting training and inference. The latter approach appears to underpin OpenAI's O1 jump in capability. So I don't know much about the O1 model. If somebody knows, I didn't quite follow this picture here. If somebody could clue me in, that would be good. Where's Julian? This was done at Stanford. So anyway, generates internal rationales, you portray sampling and custom meta tokens to mark the beginning and end of these thoughts. Approach informs reinforcement learning and showing many types of problems, strategic planning. Yeah, not quite following along. If somebody else has some comments on that, let me know.
Well, one comment is that we need to put that in our reading list.
Yeah.
For sure.
Well.
I would say that I will try to dig it up, but there's a good website which tries to track all the papers that came out in the last 6 months that potentially take the models or move the models towards more reasoning than the traditional token generation model that you have, and you have the COT and reasoning kind of explicitly guided from the external user or prompts. Now, also, I think this work probably was happening as one would predict at all the big places. OpenAI, of course, was the first one to release it. Meta has been releasing some papers in the last 1 month in this domain. So there is a very high probability that the 100,000 clusters, H100 GPU cluster that Meta has been deploying for the next generation models will probably have the reasoning in there, open source, and maybe more papers to help with the theory of it. But again, I didn't throw any light into this paper. Sorry about that, or this picture.
That's okay.
But we definitely need to study this more. Or I do, and maybe if people want in a group, we can too.
Well, we could do a group thing on it.
So what would take us there? Is it like 100,000 takes us closer, 1 million takes us even closer, or what is it there?
I don't know the answer to that. When you say 100,000, you're talking about GPUs?
Right. The thing that you were talking about with Meta, there are 100,000 H100s, and so they think that they can build a model that has more reasoning. So is the answer more GPUs?
Oh, it may be more complex than that, but scaling laws definitely on the LLM frontier or other models frontier also had somewhat of the similar findings where, of course, there is a frontier line that you reach in terms of the loss cap, but more compute power, either with better and more data or more training. I'm not sure about more training, but bigger model takes you to the better outcomes, right? But I don't know about the reasoning one. Sorry, the reason I put that out, that 100,000 GPU number, is because that's exactly what I read in an article. So I don't want to misguide that this is what the factor is in that. It could be with the, if you look at how it is sampling the thoughts in here, the picture that we have. I mean, even if you look at O1's inference time, for example, right? Uh, I don't know how many of you have tried those out there, but I'm using very extensively day in and day out. And there are times when O1 would take, without knowing the GPU cluster that is being used for inferencing, O1 mini can take a minute, minute and a half sometimes to return the response. And then it will also, it used to, maybe it still does, but I never go and look at the thought process that it has spent time trying to come up with the answer, right? Now, if inferencing is taking this long, you can put it back to training. Training also needs to be that long for each single prompt, if you may. So in some ways, maybe it is, but I'm doing somewhat of a deduction. But Jayant, I don't have a scientific answer to your or algorithmic answer to your question.
Yeah, so I was just curious. That's all. You know what I mean. So it's like, what is the barrier that we're trying to overcome? So that wasn't specifically meant for your comment either. So, yeah.
Well, I think it's this they say generate stronger internal reasoning process. So rather than just, they have a thing here, it says we visualize, as applied during training to single thought, we generate thoughts in parallel, allowing all tokens in text, and that's what they call think. The model will produce a mixture of the next tokens without a thought talk. We apply reinforce. It increases the likelihood that the thoughts that help the model predict future text get selected, I guess, while discarding thoughts in the future that are less likely to help. So it kind of thinks about this think versus talk type thing is what they're talking about. The model sort of thinks about the problem a little bit better. And it's very unclear to me based on this diagram exactly how that's going on, but maybe somebody else can, think about it. I guess, the binary selector here is, did that help the prediction or did that harm the prediction? But that seems a little too binary. Maybe, it could be neutral in the thing and it just wasted a whole bunch of CPU time. And maybe that's why Dave is seeing all that, it takes a minute just to answer, what are we having for lunch or something like that. Don't know. And here's the company, I think, which has the best name in the AI game, the Not Bad AI Company. Yeah.
So Jerry, just quickly scanning over the paper, this is a language model. It's just an LLM. So basically, these thoughts are intermediate completions. Right? So you can imagine that there you've got the tokens coming in, 42 plus 12 equals 5, and then at that moment you have to predict the next token. Right? So you could pause there and you could insert like, I don't even know, but some prompt that says, what do you think about what the next token might be, or what we need to do, or what intermediate steps are. You have some kind of prompt, and I don't know if they just do sampling or whatever, different random number seeds, but they will then grab multiple thoughts.
I see.
The part that's interesting is somehow they're going to steer it using their reinforcement learning so that the RL gives it feedback for which thoughts were actually helpful for predicting the correct next token of 4 versus which thoughts were unhelpful, so that in the future they can get it to produce mostly helpful thoughts. I haven't read the paper yet, so I don't know how that steering RL business happens. But from what I can see here, it is just an LLM. So you can run this algorithm on anything. If you have Llama 3, 7 billion on your computer, you can run this algorithm.
It's interesting then. Are they trying to teach it? I won't say teach it, but will it learn just perhaps by repetition, if nothing else, that 2 + 2 is equal to 4 in this particular case with this data? Or that 41, well, I guess 42, yeah, it's almost, you know, the sampled thought is the 2 + 2, right? And okay.
So the basic original chain of thought is break it down into steps, but it's going to be linear.
Uh-huh.
So it's do A, then B, then C, then D. Okay, right? So it's only the more recent papers where you might say, I have competing ideas and one of them's going to win.
Right.
So
but
for A, I might have like some sub thoughts that, well, one way to get A done would be do this. One way to get A done would be to do that. And so then you know, that's it looks like they're trying to use RL to sort of teach it how to have good internal thoughts, helpful internal thoughts.
This one almost is looking, you know, really how to do math, if you will. If
well,
we
I mean, for that example,
thought.
but
yeah.
The key thing
in this
is
example, yes,
this is a training time technique. Most of the other ones are after the model's frozen, let me just change the prompting. You know, and a lot of the agentic stuff is just it's a frozen model, and so let me just have you list 5 steps, and then I'm going to store them in memory, right? And then I'm going to read back step 1 and say, what would the sub steps be? And then you say A, B, C. And then you go and you do each one of those sequentially. And then I go back to my memory and say, okay, now here's 2. What are the steps? And then you say, okay, you said 2A. What text do we need for 2A? So you can imagine, like, if you just wanted it to spit out a book, right? You start by giving me a list of chapters, and then for each chapter, give me a list of sections. And even if you have a token limit where you can't do more than a few pages, you can do a whole book just by keeping track of all the things it said it needed to do. In this case, though, this is both training time and the different options are competing with each other, and somehow they're using the RL to try to tell it which thoughts were better.
Yeah. Oh, I see. Yeah. So they're giving it a higher reward, so that would bias it toward, well, if it sees 2 plus, you know, something with the 2 and another thing with the 2, that it would pick the 4 as the response.
Maybe,
Teaching it big miss. Maybe. Yeah, big maybe. Okay, where are we at time-wise here? Maybe we have time for maybe one more slide. Yeah, this is every one of their things in this deck will always have like, they're doing real great in this, but there's always a but. And this is kind of the but on this here. But where, you know, I think this first sentence sums it up. Novel tests where LLMs are unable to rely. Performance also often degrades. This suggests that we still often struggle with generalizing beyond familiar patterns without some sort of external help. And this is probably an accurate summation of where we are today. And that this other thing in the previous slide, what we saw was kind of that external, a way to give it that external help of being able to split that project up, or split the addition operation up into 2 separate parts. Yeah, let's see here. Yeah, and the one LLMs, I found this interesting. LLMs, researchers found that LLMs accurately predict direct action result, like turning the sink on about around 70% of this, 77% of the time, but struggle with the environmental effects, such as water filling a cup in a sink, only achieving 50% of that indirect change. So it's got that, yeah, it's on, but it doesn't understand what happens with it yet. And it'll be interesting to see if we ever get beyond that. Anyway, I think we're pretty much at time. Do we want to call it here, or let's see what the next one was? Yeah. oh, this is their one path to this robustness, is to have something open-endedness. So an open-ended approach of capability of generating new knowledge. And I quite didn't understand this all the way. So I think the strategy game here is like this. You try this strategy and see how well you do. And you have some ideas. You try this instead. And then you select the ideas that improves this strategy the best. But that sounds, I don't know, is this just it thinking? Is this like a thinking? You're thinking about, well, if I do this, I do that. Brian, you're shaking your head.
So the problem, this is kind of what I was talking about in my comment, where you can't simulate certain, like you don't just, part of it's a learning thing. So part of it's a looped learning thing where, yes, I do something, I say something, okay, now it's my turn to speak. So that's something you can program to an AI. But in order for it to really kind of become better, it needs to understand the human principles. Like, how do you simulate gravity to an AI? You can't. I mean, you can give it a mathematical equation, but here's a better one: undertone. When you're talking to someone and there's like a hidden message being going on, you can't like self simulate undertone to yourself or subtext to yourself.
Yeah. Interesting. Shulin, you raised your hand.
Yeah, I was like, I was thinking of like, why did you use the bi-level tree search? So for me, I would rather like give energy states to each of the strategies and kind of like evaluate like which one will have the highest energy to be selected for the current problem. So, but because like for binary trees, you only have two options, right? You're just kind of like constantly searching for two options. That's kind of like, it feels like it's kind of like a very lengthy and it probably costs a lot of time. That. So I was thinking that if I were to do that, I was thinking of like giving energy states to each of the strategy and to kind of like filter like to kind of like influence of which one will be better given the current problem.
How do you evaluate which one's better? Given you'd have to have a memory, right, of what the setup was, I guess, and see if you could apply that, I guess.
I think I'll probably train a bunch of ideas on kind of like a lot of problems and giving them different energy states based on like their scoring in those problems. And when I do the problem, and when I face a new problem, I'm going to generate a new score. I'm going to generate a score. I see kind of like the conditional score of each of the strategies given these questions. This is what I was saying. I will do that. So I'm just like not sure about the binary bi-level tree, whether that will be a good one. Yeah, just like that.
Yeah, interesting. Okay. Well, we are a little past time, so I think this is a pretty good place to stop for tonight. And I hope everybody got something out of this. We're going to go on to our third cycle at this. For those that are new to the group, we do this when we get into things. Dave will tell us, how many times, Dave, did you do when we did the Transformer? Your 1 hour talk turned into how many sessions? I don't remember.
That's also partly me.
No, it was because we asked you, but what about this? And you went and figured out what about this.
Every time you guys asked me a question, I had to go back and learn it and then do another session on that.
Yeah. We had to. I think we were like 6 or 7, but we won't be going that long. I'm hoping to finish next time, so we'll just finish up with that, or maybe I'll. As I said, I've gone through and edited their text. Maybe I'll do another pass on the editing. But I think that's it for tonight, guys, and I think it went really well. So